Here we are in the Smart Energy Lab with Ian Rowlands and off camera, Daniel Rickson from CE+T. Now, CE+T, I've known them for only a short time, but I've learnt a whole lot, particularly from Ian and off camera, Daniel, who's actually the Vice President, the Global Vice President. Is that right, Daniel?
That's right.
That sounds good. Yep.
Yep.
Ian's the country manager.
Correct.
So if you're talking to someone in Australia, it's going to be Ian indeed. So what we're going to do today is talk a bit about the product that CE+T, and I've got one example, a dummy sample here, have been working on for a long time. It's been in the market for how long, Ian?
The original genesis of the product has been out for 20 plus years, mainly in the high reliability AC backed up power space. The Sierra product we're talking about here is an evolution of a proven product.
Yep.
It's been 2 years or two and a half years now since we first released it, and it's proven very successful globally.
Wow, we haven't even said what it is. This looks a lot like a humane rat trap that I have. In fact, I've got one over there.
Yeah, well.
But it's way more interesting to our audience than that. What is this?
Essentially, it's three devices in one. It's a rectifier, it's an inverter, and it's a DC to DC converter.
Right.
Okay, and each section of the unit is fully bidirectional. So in a typical UPS application, for example, the AC would come in, get rectified onto an internal 400 volt DC bus, and that DC bus would then feed the inverter part of the module. So should the AC go, well, sorry, backtrack a bit, that DC bus is also supported by the internal DC-DC converter. So as long as that internal 400 volt bus is supported from either the AC or the DC input, the AC will be recreated by a DSP and you'll get a nice clean 230 volt sine wave output. So that comes from the genesis of the product, having a complete no-break AC supply. If you lose the AC, it's supported by the DC. And it's not an either-or scenario. You can have a blend of the AC input or the DC input supporting the AC output.
I'm losing our audience a bit. This is a lot of information.
That's a lot. I know, okay. It's a hard thing to explain.
Let's backtrack a whole long way.
Okay.
So people will often look at some product and say, oh, it's an inverter. But you just said it's actually three things.
Yes.
So it can take an AC source.
Correct.
Create DC.
Inside the module.
Inside the module.
Yes.
And charge a battery.
Yeah, through a DC-DC converter. So we have, at the moment, 3 DC bus voltages.
Yep.
48, 110, and 380 volt DC.
Right, in the same product.
Well, different models, but
different
essentially
models,
the same form factor, same product.
So you can do a high voltage battery, you can do a conventional sort of nominal 48 volt or lithium 50 something battery.
Correct.
And in between there, you've got like your 120 volt batteries.
Correct.
You said 110, but around that range.
Yeah, 110, 120. Yeah.
Right. Okay. So it can take AC and supply current to a battery from 48, 120, 380.
Correct.
It can take DC and create AC.
Correct.
Inverter function.
Correct.
Right. So and it can create AC single phase only.
No. It's a modular system.
Mm-hmm.
So basically, they're software configurable. So you can configure it that one set of modules are phase A. Another set of modules are 180 degree out of phase if you want a split phase system, or you tell them to be 120 degrees out of phase to be a 3-phase system. If you want 6 phases, you tell them to be the appropriate phase angle apart. It's all software configurable in that respect.
So this module is known as the
Sierra.
So the Sierra is notionally, in the terms of what I described, the inverter function, a single phase inverter.
Correct.
But you can have multiples of these.
Yes.
And software configure them to whatever phase relationship you require.
Correct.
So 3 of them for 3 phase.
Yes.
2 of them for split phase.
Yes.
And 1 of them for single phase.
Correct.
Now, and it just focusing on its inverter function, what sort of power level are we talking?
The module itself has got 2.7 kilowatts usable power.
Yep.
Yeah. So, and you can steer that power whichever way you want to go.
What do you mean steer?
So if you have an AC load of 1.2 kilowatts,
Yes.
then you've got, what is that, 1.5 kilowatts available for battery charging.
Oh, I see.
But if the load increases because somebody turns something on, it will automatically readjust the power flow.
Yes.
Yeah. You can do things like three-phase balancing, where you can, in a three-phase scenario, you can share power around the DC bus so that it will always present a balanced load to the output of a generator, for example, regardless of what's happening on the output.
Right. So the generator will just see a fixed load, but it may be supplying a battery and supplying some essential loads at the same time.
Yeah, you
Yes.
could, if you've got phase 2 heavily loaded, but nothing much on phase 1 or phase 3.
Yep.
As far as the generator is concerned, it's seeing a nice balanced load across all 3 phases.
So just to reiterate, that's
7 kilowatts per module.
per module. So once we go to 3-phase, we can do 3 times that.
Correct?
So whatever that is, 7.2
2?
kilowatts. 7.4, sorry. 7.4 kilowatts. Yeah, I'm trying to do my
Maths
in
on
my
the
head. On my run. But let's say that's not enough. What do we do then?
Add modules.
Add modules.
Add modules.
In parallel.
Essentially, yes.
So you could have 2 per phase.
Oh, yeah. In terms of form factor, each shelf will hold 4 modules across a 19-inch rack.
Right.
That shelf has a single AC input and a single AC output. So in a 3-phase scenario, you would have 3 shelves, so 6 rack units height.
Right.
Each shelf would be a discrete phase, but each module has a discrete DC input. So you could group the modules to be battery bank A and another group of modules to be battery bank B.
Yep.
And theoretically, you can mix your battery chemistries as well.
Oh, wow. Okay. So you can scale both per multi-phase and per phase. Is there some kind of range that you can scale to?
Depends on the application.
Yep.
The theoretical upper limit of modules on a controller platform is 900. At the moment,
900 of these.
yes.
Oh, that's huge.
Yeah.
Okay.
Yeah. At the moment, today,
Yes.
we can go to essentially 30 modules
Yes.
in a grid interactive scenario,
Yes.
and that's our upper limit today. As the time progresses, it is on our roadmap to then be able to expand that up to 900,
Wow.
I guess.
Okay. Now
Daniel's probably better placed to answer that one.
Well, go on. Daniel's going to be doing some drawing for us, actually, which you'll see, and we'll do some explainers vocally, but of course the image is going to be much better. But I wanted to finish on the 3 different modes. So we've got taking AC, creating DC. We've got it's a rectifier. We've got taking DC, inverting it and creating AC.
Yes.
What was the 3rd mode?
It's essentially, from the DC, you can backfeed the grid
Yep.
and support the load at the same time.
Okay.
Yeah. So each port is multi-directional. So you can steer the power in whichever direction you feel your application dictates.
Right. Wow. Without breaking the laws of physics.
Without breaking the laws
So
of physics.
Kirchhoff's current laws and stuff are
Absolutely.
all maintained? Great.
Well, yeah. Absolutely, yes.
Wow. So basically you can put the Sierra in the middle of a source and a load and supply it with DC from renewables like the PV and a battery.
Correct.
You've got now multiple sources and destinations for that energy and push it wherever you wish.
Correct.
Is there anything it can't do?
Make coffee.
Make coffee. Hang on, that's the load side.
That's the load side. So I don't want to use the word output port because it kind of limits the thinking. But
Yes.
we can, between the Sierra, the key thing about this is it goes in series between the source, the AC source, the grid,
Yep.
and the load.
Now I can see a diagram coming on, which I
Yeah.
think Daniel's already drawing, which is actually taking a conventional perspective where in an AC coupled situation, you would have a solar inverter, a battery inverter connected to a common AC line,
Correct.
and the loads tap onto that as well.
Yes, we don't do that.
But you kind of rub those out and go, well, actually we can do all of that within one product and
Yes.
have more flexibility.
So the load side is isolated from the input side by virtue of the fact that the source, AC source of the grid, for example, is rectified and then reconverted to AC.
Now, I can see a huge advantage there, that power quality on the grid side has no impact,
Correct.
both in terms of continuity of supply, but also quality of power. So you've got pure sine wave, right?
Yeah, so the
230 volts, pure sine wave. Who cares what the grid's doing? It's just another rough source.
if the grid floats up to 254 or wanders down to 200,
Yes.
it's irrelevant as far as the load is concerned. It's seeing a nice 230 volt sinusoid,
Yep.
which is software settable. So if you want it to be 232 volts,
Yep.
you tell the software, I want it to be 232 volts.
Right. Okay.
Okay. So, and you can do things like, I only want to pull X amount of kilowatts from the grid. It's a software setting.
Yep.
So if, for example, you're running on a generator, it's a 10 kVA genset, but you've got a high inrush current when a motor or something on the load side starts, it will maintain that constant load on the generator and suck the peak out of the battery.
Gotcha.
So you can easily software configure it for peak shaving, whether it's the grid or a genset. That's up to your control and your application.
Okay. Now we've dived into kind of the tech of the product, but maybe we should just backtrack a bit further back to CE+T in itself.
Okay.
So the name's unusual. It's 3 letters with a plus in the middle.
Yeah.
Tell me a bit about the history of the company.
Okay, I'm going to use my best French.
Yes.
And my colleagues will kill me. It stands for Construction Électronique and Télécommunication.
Okay.
Okay, we're a Belgian company. We've been operating since before World War II, early 1930s. The company got into power electronics in the early 1960s through emergency lighting. We're a group of companies. We build specialist power supplies for the CERN cyclotron, for example.
Wow. Running these things.
No, completely different. So it's the company has a broad range of interests, but it's all centered around power electronics.
Yes.
The CE+T itself, the division I work for, we largely sell into the embedded market where 7.9 reliability is.
Hang on, I'm an acronym blocker.
Okay.
What's 7.9 reliability?
It's 99.99999% reliability.
7 nines.
7 nines.
Wow. Okay.
So
what's that in minutes per year?
Thanks for the heads up on that one.
That could be a Daniel question.
Yeah.
Well, it's probably a matter of seconds.
Seconds per year. Okay, I think I can cope with that.
So like railway as an example,
Yes.
or if the signalling goes down, the train stops
So essentially saying that CE+T have been in critical power supply systems,
for a very long time.
very long time. So deep experience in this area.
Yeah. So the brand name is well known in certain industries.
Mm-hmm.
Unfortunately, the renewables industry isn't one of them, from my perspective.
Yep.
Yeah, which is why we're having this chat, I guess. But we've been supplying in Australia to companies like Telstra for 15, 20 years into the telecommunications network. We supply Australian industry with embedded product. Our product is typically sold through a channel partner model, so it's within another brand's piece of final equipment.
Right. So you don't just buy one of these and go, and I'm
No.
going to run my facility off this.
No.
This becomes an integral component to a finished system.
Correct.
So you need to work with third parties on this.
Correct. Essentially, yes.
Yeah.
So we're
We call
working
them
with
channel partners.
channel partners is what we call them.
Yep.
So, as we were talking earlier, there's different industry sectors have different requirements.
Yep.
So we supply, if you're looking at diesel replacement or abatement into the mining industry, for example,
Yep.
the conditions in the Pilbara are very different to a dairy farm, for example, or a railway or a telco operator. Yeah, the telco operator is going to have typically a nice air-conditioned, controlled, clean environment.
Yep.
Or a data center will be the same, but out in the Pilbara, it's not exactly friendly. So you can't we can't be all things to all people. So the way we operate is we find organisations within Australia who have niche markets, and they use our product as like the engine, if you would take it that way, as the engine in the vehicle to supply the power for that specific market. So that's where we sit in the firmament. So yeah, we're not supplying a cookie cutter, one size, this is what we sell. Our product can be tailored to suit specific markets. And we have relationships with a number of Australian manufacturers that do specialise in their specific market segments.
So Ian, you work with batteries, but any particular chemistry?
No, typically we work with lead acid in the UPS type scenario, but nickel cadmium is favoured in the rail industry for various reasons. But in the renewables arena, obviously lithium. Now we can operate with lithium batteries that don't have a communication port on the battery management system, but we are integrated with a number of manufacturers and we can communicate with their BMS. We're integrated with flow batteries, salt batteries. We have a nickel metal hydride battery ourselves, but that once again is a very short discharge for UPS type applications.
I think you just covered everything.
Yeah, I think we're pretty battery agnostic.
Right, okay. So that integration means that the charging, voltage, profiling of the battery is dealt with by this product. And you've also got the communications, particularly with managed batteries.
Correct. Yeah.
Right.
So yeah, the charge profile for each battery is settable in the overall system architecture software.
Right. I can see that you're very central to energy. Basically, you've got storage devices, you've got generation devices, and you sit in the middle of all that and
Correct.
manage that.
Yeah.
In terms of management, how is that controlled and configured?
The topology of the system is quite interesting. We have in a traditional rectifier sort of system where I come from, the system configuration would typically live in the system controller. With in the company DNA, we have a philosophy of no break, totally reliable power. So in our system, the configuration file actually lives in the module, not in the system. In here, yeah.
Right.
And there's a dual redundant communication bus between modules.
Now, hang on, redundant, meaning if we've got 3 of these on one phase and one fails.
Yeah, that's fine. There's 3 levels of disconnect within each module.
Wow.
It's impossible for one module to take out a system.
That's where that 7-9 business comes along.
Exactly.
Right. So
and so you can actually take the controller out of the system and the modules, you'll get an alarm obviously, but the modules will still perform as per the controller settings because the config is living in the module.
do you have to shut the whole system down to change one of these units?
No, completely hot swappable.
Right.
So just you'll get an alarm, a module has failed, there'll be a red light on the front telling you it's not happy. You come along, you pull the module out, slide the module in, and the modules either side or surrounding it will configure the new module. It takes 10, 20, 30 seconds for the module to get configured. Little flashing light. Once that's done, it comes on. Walk away. Job done.
Wow. Look, I'm smiling because I'm just thinking about the times that on a Sunday before Christmas, a customer has rung me up and said their inverter's failed, and I have to rush out to their property and take a spare inverter and spend about 2 hours taking off the wall, replacing it. If it was one of these systems, I'd just take a module with me, possibly even just send it to them and say, pull it out and push it in.
Precisely. and because you can configure it to have N+1, N+2 modules as well.
Do you have to pre-program them before you do that, or do they pick the program up from the other modules?
No, it self-configures.
Self-configures.
You don't need to do anything.
Is there like a master unit, or
No.
they're all masters?
There is no master-slave relationship because by definition, if you have a master and slaves, then the master becomes a single point of failure.
Gotcha.
And we don't have single points of failure.
All right, that 7-9 keeps coming up again.
Yeah.
Right. Wow.
Yeah. So you can configure the system and tell it what sort of level of redundancy it does have.
Yes.
And okay, if a module does fail for whatever reason, you're not losing an entire system. You're only, okay, I'm down 2.7 kilowatts.
Yes.
Okay, I'm a
Yes.
little bit constrained, or
Yes.
if you've got an N+1 redundancy, you're not constrained at all. Yeah?
Yep.
And it's easy to fix. So you could theoretically send by Mr. DHL or FedEx a module out to wherever,
Yes.
and tell the guy out on site, take that one with the red light out, slide the new one in,
Yes.
job done.
Right. So it doesn't require a licensed electrician to do this. There's no live parts.
No,
Right. So the end user can do the hot swapping. You
precisely.
could even have spare units on site if it's a really mission critical application.
Yeah, but if you're going to do that, you might as well put it in the slot as an N plus redundancy.
Oh, of course. So you oversize the system basically with the spare unit.
It's
Yeah.
completely up to you
Right.
how you want to configure it.
Hang on. You mean it's just not working until it's needed? It's just sitting there.
No, it will be operational,
Right.
and yeah, what level of power consumption it has can be configured.
Yep.
But essentially, yeah, if
Ah.
that's a problem to you, just leave it on the shelf. If it's not, leave it in the system. It depends on the outcome you want to get and how critical your loads are.
I get you. On the other side of that, this redundancy idea, or this hot swappable, what about upgradability? Is that possible too? Like you've got 4 of these and you've got another empty rack. Can you just add more?
Yes, absolutely. So, and once again, this comes back to the objective of the channel partner and what
Right.
market they're selling into.
Yeah, right.
So, what we tend to be doing at the moment is selling a standard sort of racking system,
Yes.
and then we'll put blank modules in the empty slots, and if they want 12 kilowatts, populate it with 12 kilowatts worth.
Right.
But then if another customer comes along and they want 15, okay, just put more modules in, less blanks.
Right.
Yeah, so we standardize more. Well, the channel partner would standardize on a size and format appropriate for their target market
Yes.
with that scalability.
And they don't have to stock 7 different ranges of product. It's one product with configurability over a huge range of output powers and functions and features.
Precisely.
I get it now. But also from a customer's point of view, they could actually have an upgradable system that they think this is going to be big enough, but then the loads change and they
Yeah.
need more and they've got those spare slots.
Exactly.
Right. Okay.
So it's really easy to do.
Yep. Yep.
Yeah, so you're not having to send someone out to bolt stuff on a wall, power the system down,
Yep.
get involved with ducting, terminations, all of that sort of stuff to add inverters.
Now, with this upgradability at a later stage scenario, now I've been caught out by this with some batteries where modular batteries, they say, yeah, you can upgrade this system later on by adding more batteries. And then 6 months later, they say, we don't make that model anymore. So you get caught by the fact that the product's changed. Now, would this product be upgradable a year later?
As in, you're talking about the life cycle of the Sierra module itself?
Yeah, like all the connections are the same. They still talk to each other.
Yeah, so it's an industrial product. So
Right.
typically in an industrial scenario, it's a 15-year life product.
Yep.
Okay, without essentially maintenance apart from the obvious cleaning. Yeah. If we do decide to upgrade, you've got a 10-year warning of end of life.
10-year. Wow. Okay. Well,
That's common
that's
in
what
the
I'm going at.
industrial space.
That's different than 6 months later. Sorry, we don't make that anymore.
No.
You'll have to buy a whole new set.
No, so
Right.
I'm still selling product that we
Yes.
designed back in the late 80s.
Yes.
Yeah, it's still
yes.
supported.
And this is the heritage of the company, which is
embedded
embedded-
industrial applications where, yeah,
things can change over time, but the product still will work. Newer versions with older. Or
exactly.
all right, cool. You mentioned no, we didn't mention cooling. I was going to ask a bit about temperature too. Like, it looks like you've got ventilation on this unit. Is it actively managed by the module itself?
The module has a fan in it.
Yep.
The fan has a 60,000 year, 60,000 year.
I'm holding you to that.
Was put in by the Egyptians. 60,000 hour life,
Yep.
and it's a field replaceable part.
Oh, right.
Okay, so that's the only maintenance that's needed on the unit.
Yep.
Okay. What was the second part of the question?
Oh, it really was it actively managing its own
Oh,
thermals?
okay. So in terms of temperature range,
Yep.
it's fully rated up to 50 degrees with a D rating up to 75.
Yep.
70, 75, can't remember off the top of my head. Yeah.
Wow.
So
Okay.
that's, yeah.
So if you put these in a back shed, for instance, they'll operate their own cooling to maintain their operating temperatures internally.
Correct.
Yeah. There will be some filtration requirements though? Like, what about dust and dirt?
Once again, this comes back to the channel partner's
Right.
selection.
So they need to think about how they package this up, how they protect it from the environment.
Precisely.
So,
In a data center environment, IP21 cabinet
Yep.
without a front door, hey, fine,
Yep.
not a problem. It's a clean, happy place.
Yep.
You wouldn't want to do that out on the Pilbara. Yeah.
Now, what I'm curious about is you've been in sort of industrial applications, but you've moved into renewable applications now. Why this move?
It's obvious that with the energy transition and the way the world's heading, that this is a growing and emerging market. We've been doing high reliability energy systems with energy storage for a very long time, and we're good at it. It's not, you don't have to be a rocket scientist to figure this is a market we should move into.
Yeah.
Essentially.
Yep.
Yeah, that's basically it. Commercial reasons.
And given that renewables generally come from a DC source, that's what you do so well, is manage DC and AC together.
Precisely.
Yeah.
Yeah. And in terms of coupling PV, there's a number of ways you can couple PV onto it. So as it's a series connection with the source, the ultimate of whether it be grid or a diesel.
Yep.
On between the output of the unit and the load, we can couple your standard SMA, N-phase, grid tie inverter.
So you can integrate with other brands on the AC load side.
Yes.
How do you sort of manage that? Like, how do you manage charging of the battery and stopping it from being overcharged when you've got a third party on the load side generating AC power? Well, let's say you mentioned SMA. So you've got an SMA inverter. I think this is a Daniel diagram.
This is where a diagram's needed. Essentially, what will happen if the module is being fed from the grid,
Yes.
the output will phase synchronize with the input.
Yes.
If the grid is not there,
Yes.
the Sierra will simulate the grid
Yes.
between its
So
feed
voltage
to the
source.
load.
Yep. Okay.
Yeah. So it will frequency or voltage control the SMA by the AS4777 dictated demand response mechanism.
Gotcha. I understand.
Okay.
Yeah. Yep.
But our controller will also talk to the SMA via Modbus. And it's
Really?
Yeah.
Okay. So you have Modbus managed solar as well.
Yeah.
Wow.
And there's a number of inverter manufacturers. I'm just picking SMA at random.
Yes.
N-phase is another.
Yes.
Okay. Or you can couple onto the DC bus via an MPPT platform as well.
Right.
So the advantages, and you could have both at the same time.
Now, hang on. When you mentioned DC coupling via an MPPT.
Onto the DC bus.
What, using the Sierra?
No, it would be
A separate product.
a separate product.
So you've got an MPPT. Gotcha.
We will have an MPPT module very shortly.
Right. Okay.
Okay, so advantages of coupling both ways.
Yep.
If you're AC coupled between the Sierra and the load, you've got a high efficiency source from the PV straight to the load, and any surplus you can then feed back through the Sierra and charge into the battery. Your battery's full and you're producing more PV than the load requires, it will throttle back the PV inverter.
Using either frequency or Modbus control.
Precisely.
Right. What about the ratios of those? I know with many of the AC coupled solutions I have here at the lab, it's a one-to-one relationship. That means if I have 2.7 kilowatts of AC output power on this, I can't have more than 2.7
No,
kilowatts.
2 to 1.
It's 2 to 1.
Well, I picked that because that's common.
Right. Okay.
But I'm not sure that there is an actual upper limit. I don't want to quote a number there, but
Okay.
2 to 1's fine.
Yeah. It might be a Daniel question.
Yes, typically the competition is having a ratio 1-to-1.
Yes.
Your question is perfectly valid. We do not have that limitation.
Wow.
We can go to 2 or even further, but further to 2 it doesn't make a lot of sense.
Because you can't do anything with the energy.
Absolutely, you have to curtail.
Yeah. Okay. Wow. That's quite a big plus because, we love solar here in Australia, and people like to have lots of it, and they will often oversize the solar side of installation.
Yeah.
So having that ratio is really useful to be able to well, every day isn't a sunny day, as I tell people. So on those overcast days, your oversized solar is actually producing a 1-to-1 relationship, not a 2-to-1.
Yeah.
Yeah.
So that's on the AC coupled side.
Yep.
On the DC coupled side, you can also have that in there as well. So the DC coupled solar can be then dedicated to maintaining the battery.
Yep.
And that's a more efficient way of ensuring that you're capturing the PV into the energy storage. So when the sun does come down, you're then running the load off the battery.
And also you have no relationship with the inverter size or the output rating of the Sierra, because it's only the maximum C rate of the battery that you're concerned with.
Correct.
Right, so even more solar.
And then we're talking to the battery theoretically, if it's got a communication port, so we know exactly the state of charge of the battery and how happy the battery is.
Yeah.
And we control what's going into the battery.
Now, so this doesn't sound like a hagiography. There's got to be some limitations. If you're in an off-grid situation and you've got a generator for backup, you have to size your Sierras to meet the peak load. That's my understanding. Is that correct?
Correct.
You can't just say, oh, the generator will pick up the difference.
No.
No. So the generator...
The power has to flow through the Sierra system. It's not like it's not like in shunt mode there's a piece of wire.
Right. Okay. So because it's in series mode, the output of the generator is only going to be charging batteries. It's not going to be supplying the load. You could have the changeover switch, but that's not going to help. So the Sierra actually has to be sized for the peak load. How do you get on with overload ratings? Do you have an overload rating, or is 2.7 it?
No, it does do an overload. It will overload to 150%.
Okay.
Okay, and it will stay at 150% for a period of time, which I think is 2 minutes. Then come back to 100% load.
Yep.
And then try again to go to 150%, and it will do that indefinitely. If you won't do that. It will do that indefinitely if you disable the software. There is software that says, "Hey, we're doing this.
Yeah,
this is stupid. There's
There'll
something
be thermal
wrong."
limits too. It's getting hot. So.
No. It will just keep doing that.
Right. Wow.
Okay, but it's pointless doing that for all year.
Yes.
So it will do it over a fixed period of time, which is adjustable up to a certain limit, and then go, "Hey, look, there's something wrong here."
Yep.
And you're going to be getting alarms by this point.
Right. Okay. And I mean, in a way, it's not a problem because of your modularity. You don't say, well, we've only got these 3 products. You have to choose the 5, the 10, or the 15.
Yeah.
Right.
You just scale it.
You just scale it. And this oversizing problem or overload problem goes away.
Exactly.
Yep. In fact, as a designer, you can get it wrong because the customer's not honest with their loads. And if you've got those spare modules or spare spots in the rack, you can always go, well, actually, we just need one more.
If you're putting a power system into a domestic or industrial or this is long life cycle product.
Yeah.
It's designed to be there for a while. You don't know what's going to happen 5 years down the track.
Yep.
Your load might get smaller. Your load may increase.
Yep.
Yeah, it's scalable.
Yep. Okay.
You've got the flexibility to adjust as circumstances adjust.
Yes.
And you've got the assurance that the product, it's a relatively new product.
Yep.
Yeah, it will have at least 15 years life as it is at the moment.
Yep.
Clearly there will probably be firmware upgrades.
Yes.
We do have plans for enhancements, but fundamentally the hardware is going to be a solid platform well into the future.
Wow. So, there's scenarios where you have interruption to supply, and that's one of the big pluses that customers think about when they have a battery system with an inverter behind it or in front of it. But this product can work even better than just being a backup solution when there's a disconnection from, say, the supply, like the grid goes down or the grid goes dirty, so the volts go high or low. It will continue to provide pure output. Now, what's the advantage of that?
Well, yeah, in the scenario if the grid goes high under the regulations, it has to disconnect and island itself from the grid, and that's what would happen with a normal grid tie inverter. But because we're coupled between our product and the load, we are effectively recreating the grid. So as far as the solar inverter's concerned, the grid never went away.
You mean when you say the solar inverter, the AC coupled
The
solar,
AC coupled solar,
it only ever sees the output of the Sierra?
as far as it's concerned, the output of the Sierra is the grid. And because we're creating the grid, regardless of what's happening on the incoming side,
Yep.
the solar inverter keeps chugging away happily. And because the voltage is set by the DSP, and you've set it,
Yep.
it's going to be a rock solid 230 volts. So the grid tie inverter really is having a bit of a holiday. It's seeing a constant voltage the whole time. The only time we may throttle it is the battery's full and we're producing far more PV than we can actually absorb.
Right, I get you. Yeah, so it's becoming more and more of a problem in Australia that we're seeing high grid volts in the middle of the day.
Yeah.
And that's often causing grid-tied inverters to disconnect from the grid because they have to, which means if you happen to have a battery and an AC-coupled solar inverter on that same output, you're going to lose it for a little while. Well, it recalibrates, it goes through that black start process, typically a couple of minutes.
Yep.
So you're going to have 2 minutes of downtime on your generation, which you didn't need to have. And that's where the Sierra can solve that problem.
Yeah, that won't happen.
Wow, that's a big plus.
Yeah, you're maximizing.
Yeah.
Yeah, you're either using it
Yeah.
or putting it into your battery or both.
So if I
And it's not being disrupted regardless of what's happening on the grid.
So if I went and got a voltmeter and I put it on the grid side, could I measure a different voltage than the output of the Sierra?
Yes.
Right. So that confirms to me that there is that separation.
Oh, absolutely. It's
Yeah.
yeah, absolutely. As I said, there's a wide voltage input range.
Yep.
Yeah, but the output will be what you told it to be in the software.
Okay. All right. Can I export to the grid? with the Sierra?
Absolutely, yes.
Is it using the same product or a separate product?
No, it's exactly the same product. So in terms of the AS4777
Yep.
approval, we're in the final stages of going through the test reports and all the laboratory testing. So I would anticipate full listing and Clean Energy Council approval in the sort of August this year timeframe.
Right.
Yeah. At the moment, it does have EN 62109.1 and .2, so it's fine for off-grid applications at this point.
Right. Yep. Yep. That's great. So is the product being sold in Australia at the moment? Like not on grid, but off grid?
It's being sold into the rail industry.
Yep.
Yeah. It's been sold into other industry segments, mainly in that UPS application. Have a number of channel partners doing final design work on their enclosures and testing it for their specific markets at the moment. Yes.
Right. Wow, I'm excited. Honestly, I think this is kind of the future, particularly for the off-grid market, is having modularity. You solve so many problems.
Yeah.
That expandability, multi-phase, redundancy, all of that is a real problem at the moment for a designer. And you solve that with this modularity. And you've got that history of industrial applications and the 7-9 uptime.
It as I said at the beginning of the chat, it's an evolution of an existing product that has been in the marketplace for a very long time. So the bones of the unit are a proven platform.
Yep.
The hard part about this conversation is because you can do so many things, whether AC coupled, DC coupled, both. You can have sodium batteries, you can have flow battery, you can have lithium battery, you can mix. Yeah, you can do all sorts of things like that. It's really, really very difficult to convey the permutations of what you can actually implement. And it's very much, it's a struggle I constantly have. And that's where the channel partner once again comes into the picture, is they understand their market. Yeah. We don't know everything in terms of application. Yeah, it's very much up to local industry that has expertise and knowledge of the specifics of their customers to take our engine, configure it in such a way that it becomes a vehicle to solve the problem for that market.
Now, Ian, there's some clever things you were telling me about I want to share with the audience, which is you can use this product, the Sierra, to create all sorts of kind of combinations from, say, poor quality power or single phase and create three-phase or split phase? How does that
Correct.
work?
Essentially, the DC bus is shared between the modules. Okay, so like if you were to feed it from a single phase, for example, a single phase comes in, you share the power out of the DC port and out of the AC port. So the AC port feeds that phase one. The DC coming out of the modules will feed into the modules on phase two and phase three. You've told them they're 120 degrees or 180 degrees phase relationship to the incoming SIG power. So by sharing the power around the DC bus, you're creating phase two and phase three.
So the DC bus is like a generic pool that you can draw from to create whatever you need.
Correct.
And you can supply it from whatever you've got.
Correct. So if you wanted to, onto the DC bus, you could take a generic rectifier platform, for example, and couple an AC generator to it. So you've got no phase synchronization problems all of a sudden. Easy, yeah? We will have an MPPT module to couple onto that DC bus as well shortly. So you can start coupling multiple sources onto the DC bus to generate phase one, phase two, phase three. Or if, as in our discussion, if you fed from a swirl line, for example, you could use your PV on the output side, like put a three-phase grid tie inverter on the output, so you're utilizing your PV production with the Sierras being the grid as far as the PV inverter is concerned. They're operating, you're maximizing your PV, and surplus, you're charging your batteries. You've got a swirl line there, like Sydney had a terrific summer with rain, yeah? So if your PV yield is not happening for whatever reason, you might leave your swirl line there just to charge your batteries overnight, or chop the thing down. You've got you can couple on with a diesel, whether onto the AC input of the Sierras or through a rectifier platform onto the DC buses of the Sierras. There's more than one way to skin this particular problem.
Right.
It's you just got to be a bit creative.
Look, I might explain something to my audience, and it might be a little bit controversial, but really I would propose that the Sierra can do something which allows you to be kind of independent from the grid to the point where whether you need to apply to install a system and be limited on inverter capacity may not apply. You're not paralleling with the grid. So as far as the grid's concerned, the Sierra is just a load. It's just like an air conditioner.
Exactly.
Right? So there's actually no safety risk. It's not going to energize the grid and make it unsafe if there's a grid outage. It's just going to disconnect the moment the grid fails.
Yeah, or look at it as though it's a UPS.
Yep.
Yeah, so it's a pure load. Why even bother re-injecting in one level? You're creating and you're maximizing your PV yield, whether it's AC or DC coupled. So you're making your own electricity essentially all of the time, and the grid is there as the outlier event that you might need a couple of times a year.
Yep.
Should the weather be appalling like it has been in Sydney over summer and you're just not getting what you need in terms of PV.
I mean, I've had many customers ring me and say, I want more solar. And I go, well, actually, you're up to your limit because you've got a 5 kilowatt inverter and a 5 kilowatt battery inverter. So that's 10 kilowatts of inverter capacity on a single phase. We won't get an application approved for that because you're paralleling 10 kilowatts of inverter power with the grid. But I could say, well, it's not a problem with the Sierra.
Yeah, we're on the other side.
You're on the other side of that DC bus.
Yeah.
Yep.
Yeah, exactly.
Right.
So knock yourself out.
Yeah. Cool.
It is. Yeah. So, what can I say? It is really, it's really hard to explain how, just using words, how many different potential ways there are to configure the system to achieve an outcome that suits your load requirements and can operate in a way that suits your environmental parameters, whether they be latitude, longitude, or financial constraints or whatever. Yeah, it's and once again I come back to the channel partners. We can't think of everything. And it's been a really interesting exercise working for CE+T, talking to various people who operate in industries I've never been exposed to, and the problems they face, and particularly obviously with regard to energy supply, and coming up with creative ways to solve their specific industry problem.
Ian, I think we've got a solution for you. While you've been waving your arms trying to explain this energy flow, Daniel's been drawing it all.
He has.
Which no doubt everyone's been looking at while we've been chatting. But yeah, it is a tough one to explain, but I think we're getting there.
Yeah, a picture is worth 1,000 words.
Yep.
I can knock myself out talking and waving my arms around Italian style. But yeah, the pictures.
Cool.
Champion. Okay.
You know, when you're at a conference and you bump into someone and they want to know about you, you've got to give that elevator pitch. But I'm suggesting to you, Ian, that your elevator pitch is in reverse. We don't do X, Y, and Z.
Yeah.
Everything else, no problem.
Yeah, it's a challenge. Yeah,
Because you do so many things, it's pretty hard to pack that into the 2, 3,
in
4s.
25 words or less. Yeah.
Right. Well, Ian, it's been great chatting with you, and Daniel off camera. So, yeah, I really look forward to having a play with these one day. But we'll see.
I'll look forward to seeing you again. Thank you very much for your time. It's been an unmitigated pleasure, I have to say.
Thanks, Ian.
No problem.
Okay.
Cheers, mate.
See ya.